Hey everyone, and welcome. Today, we're going to dive into the world of computer programming by taking a look at one of the most important languages ever made, Java. We're going to unpack how we got from speaking to computers in just ones and zeros to building the incredible apps we all use every single day. All right, let's get into it.
So, have you ever been just scrolling through your phone and had that thought pop into your head? Like, what is actually going on in there to make this happen? How does a tap on a screen magically turn into food showing up at your door or a photo getting posted for your friends to see? Well, the answer is all about language, the special language that bridges our world with the world of the machine.
And this slide? This just perfectly sums up the challenge. On the left, you got a super simple human idea, add two numbers. But on the right, that's what a computer actually gets. It's just a long stream of ones and zeros. Now, can you imagine trying to build an entire app using just that binary code? It would be unbelievably slow and just painfully difficult. So that brings us right to our first big topic, this fundamental communication gap, this barrier between us and the machines we want to talk to. See, at its very core, every computer speaks its own native tongue, which we call machine language. It's basically a list of super basic commands, all written in binary. It's the most direct way to tell a computer what to do, but for a person trying to write it, well, it's a complete nightmare. So the early pioneers of computing knew they needed to build a bridge over that communication gap. And this is what led to the very first programming languages, tools designed to make this whole process a lot more human-friendly. Okay, so one of the first big steps up from binary was something called assembly language. Instead of a mess of ones and zeros, programmers could write a short, memorable command, a mnemonic, like ADF3. Then a program called an assembler would do the heavy lifting of translating that one command into the proper machine code. It was a huge leap forward for sure, but it was still very basic and tied directly to one specific type of computer. But the real, honest-to-goodness breakthrough, that came with what we now call high-level languages. This was a total revolution because it let programmers stop thinking so much about the machine's language and start focusing on the actual problem they were trying to solve. I mean, just look at how readable this is. All of a sudden, programmers could write code that looked a whole lot more like simple algebra or, almost plain English. You don't need a computer science degree to figure out this line of code is calculating the area of a circle. This just blew the doors wide open and made programming so much more accessible. So how does this magic work? Well, remember the assembler, which did that simple one-to-one translation? High-level languages use a way more powerful tool called a compiler. Instead of just translating line by line, the compiler takes the entire human-readable program and translates it all at once into a complete machine language file that the computer can finally run. And this new way of doing things led to an absolute explosion of different languages, each one kind of designed for a specific job. You had COBOL for business, Fortran for scientific number crunching, and really powerful languages like C and C++. This was the exciting and crowded world that Java was about to be born into. But see, Java wasn't just another language thrown onto the pile. It showed up at this perfect moment in history with a big idea that was absolutely tailor-made for the biggest thing happening in technology at the time, the rise of the internet. Java came onto the scene with this huge promise to be the language of the internet. It was designed from the ground up to let developers build one application that could run across a whole network of different computers and servers, which is, of course, exactly what the web needed. Its story is pretty cool, actually. It started way back in '91 at Sun Microsystems as Project Oak, and it was originally meant for interactive TV, of all things. It had a few name changes, including Green, but was eventually named Java. Yep, literally because of the coffee its creators loved to drink. When it was released to the public in 1995, it found its true destiny in building apps for the brand new World Wide Web. So what was Java's big secret? What was its magic trick that made it so different from everything else? Well, it all boils down to this one simple but incredibly powerful idea. Okay, let's walk through it. First, a programmer writes their code just like normal. But, and this is the most important part, when the Java compiler does its thing, it doesn't create machine code for one specific computer. Nope. It creates this universal intermediate language called bytecode. Think of bytecode as a master key. It doesn't open any one door directly, but it can be used by a special kind of lock, the JVM, that can be installed on any door. And this whole idea led to Java's legendary motto, compile once, run anywhere. This was an absolute game changer. Before Java,
With a language like C++, you'd have to compile your code for Windows, then do it all over again for a Mac, and then again for Linux. But with Java, you just compiled it one time, and that single bytecode file could be sent to any machine in the world, as long as it had that special lock, the JVM, installed. So you can really think of the JVM as this little universal translator that lives inside each computer. The bytecode is the universal language, and the JVM's job is to translate it, on the fly, into the specific machine code that its own computer can understand. This is the secret sauce that gives Java its incredible portability.
Okay, so this flowchart right here puts it all together and shows the whole journey. On the far left, you see the human-readable source code. That gets fed into the compiler, which spits out the platform-neutral bytecode. And then that bytecode can be sent to literally any device, a server, your laptop, a phone, where the local Java virtual machine takes over and runs it. It's this elegant system that made Java just perfect for the internet. And that powerful idea has given Java a truly massive legacy. It's still powering a huge, huge part of our digital world, even today.
And to handle all these different jobs, Java was split into a few different versions or editions. We had the Standard Edition, or J2SE, for your everyday desktop apps. Then there was the Enterprise Edition, J2EE, for the huge, powerful server applications that run big companies. And there was even a Micro Edition, J2ME, which is what brought Java to the very first mobile phones and other small gadgets long before our modern smartphones came along. So when you look back, Java was clearly the language that was purpose-built to solve the problems of the internet age. And that leaves us with one last question to chew on. As we dive headfirst into this new era that's being defined by AI, what will the programming language of this age look like? What new kinds of problems will it have to solve?